This is the video solution of exam 22 of Advanced Computer Skills exam. Okay, let's see. The file that we use is file sleep.sav. It's one of the files which was given during the lesson on the website. Display through appropriate graphical and non-graphical tools a description for variable alcohol and caffeine. Okay, you just take a look at the code book, alcohol and caffeine. Where are they? Alcohol and caffeine here. Okay, how many alcoholic drinks per day? It's clearly here the two questions. It's clearly a scale variable. Okay, so non-graphical tool, well, the descriptive statistics, don't do the frequencies. You see here a problem which you will go through all this exam. You don't see clearly the variable name, so either you enlarge it a lot, okay, or much better, you switch to display variable name. So you right click and display variable name, and this will do the task, alcohol and caffeine. Okay, descriptive statistics. We have a graphical tool also. Chart builder is the histogram, clearly. Same thing here, display variable name. Alcohol. Or I do not want to see display normal curve because we are not investigating whether the variable is normally distributed. Graph chart builder, same thing but with caffeine. The true histogram looks very odd. It's not required by the exam, but if at the end you have time, it's not so bad to open the chart editor and change the binning. For example, 10 intervals should be enough here. Okay, at this point it's not a bad idea to save the file. So file, save as, locate the directory where you were working, usually the desktop. In this case I was working in new folder. Give it the proper name. If you look at exam, sleep.spv. So sleep. You don't need to type .spv, it will be typed automatically. Okay, saved. Test through appropriate parametric and non-parametric tests whether variable alcohol depends on sex. We have said that variable alcohol is scale, sex is clearly nominal with two values. Okay, let's take a look at these two values. Sex, gender, 0 female and 1 male. Oh, there is a mistake here, it should be sex. Should be called sex and not gender. 0 female, 1 male. So the tools are clearly the student test and the man Whitney. So analyze, compare means, independent sample t-test. Sex goes here and alcohol goes here. Define groups. Let's take a look. 0, 1. Okay. Well. Okay, males seem to drink more. Analyze non-parametric test, independent samples. Sex goes here. And here you cannot switch. Okay. Man Whitney. If you prefer the old one, it's here. Okay, I prefer it, but this is the new one. Test with all the non-graphical tools you know whether there is a relation between caffeine and the hour need. So the hour you need to sleep and how much caffeine do you drink. Usually there should be an inverse relation. So the non-graphical tools we know are the true correlation coefficient, Spearman and Pearson, because hour need is scale and caffeine is scale. So, correlate, bivariate, caffeine, hours need, Pearson and Spearman. Okay, clearly a negative coefficient. The more caffeine you drink, the less you need to sleep. Record the 7 variables impact 1 to impact 7, keeping the same name, so you record into the same variable with appropriate labels, grouping them as 1 to 3 goes to 1, 4 to 6 goes to 2, and 3 to 7, 7 to 10 goes to 3. So it's a record into same value. No, nothing is written what happens to missing values, etc., etc. So we don't care. Transform record into same variable. Impact 1 to impact 7. Okay. It's clearly a good idea to do all of them together and not one by one. 1 to 3, 1 add 4 to 6, 2 add 7 to 10, 3 add. Okay, if you really want, you can go system missing goes to system missing, but this was done in any system and user missing goes to user system missing, just to be sure, but it's not required. Okay, let's take a look whether it was really recorded or not, because I never trust. Okay, yes, you can see. We have a problem of labels now, because the variables had labels. Had labels for 1 to 10. Now we should put labels for 1 to 3. So 1 was less, change. 10 must be removed. 2 was average, add, and 3 was much. Much, I said, not much. Add. Okay. Check. Where is it? Ah, I did it only for impact 1. Let's do it also for the other one. Well, it's not necessary to do it, you just copy. Try to select all of them, which is not an easy task. Okay. Paste. Done. Save. Save also the output. Build a box plot displaying tired, consider a scale, with driver sleep, with red box and thick green median. Okay, tired, so it's scale, so it's a variable which is on the vertical side. Driver sleep, what is it? Driver sleep, driver sleep. Ever fallen asleep while driving? Yes, no, so it's clearly nominal. Box plot. So tired is here. Driver sleep, you can see it's nominal. There is also the symbol goes here. Okay. So the person who feels more tired have fallen asleep while driving. A red box, so double click, red, apply. Thick green median, so thick and green. This one. Thicker. Okay. Okay. Close. Save. Build a linear regression model and a scatter plot with a regression line for weight by height. They are clearly scale. Let's check if you don't trust me. But it's weight in kilogram and height in centimeters. So weight by height, obviously weight depends on height and not vice versa. So height on the vertical axis and weight on the horizontal axis. It's also clear right here, weight by height. It means that weight depends on height. So first of all, the regression model. Analyze regression linear. Weight. Where is weight? By height. Okay. Done. Let's see. A square. 3. Coefficients. 0.8. For each centimeters, you gain 0.8 kilograms. Scatter plot. Well, you need to build it separately unless you use as a regression model the curve estimation. In this case, the linear regression, the scatter plot is built automatically. I prefer to build this separately. Scatter. Wait. We need also the regression line. Let's see whether it's here. No, doesn't seem to be here. So we'll put it later. Element properties, maybe. No. Options. No. Okay, we'll put it later. This is the scatter plot. Double click. Regression line is not this one. Is this one. Okay, linear. Okay, as it is obvious, you can see there is a clearly, apart from this strange person, there is a clearly dependence of weight by height. Okay, we save. Build an index called sleeper using variables our width, our week working days, our weekend, our need, trouble sleep. 3, 3, 2, 10. Using the first three variable, using for the first three variable a minimum of 0 and a maximum of 12. So the first three variable is how many hours to sleep. We take a minimum of 0 and a maximum of 12. And trouble sleep, let's see what trouble sleep is. Trouble sleep. Yes, no. Okay, so yes, 1 and no 2. So minimum of 1 and maximum of 2. Let's build the index. Sleep. So 3. Minus 0. I put the minus 0 even though it's not necessary. Okay, I put a big parenthesis around. Divided by, well, the maximum, I calculate it manually here, 3 by 12 plus 3 by 12 plus 2 by our needed is 12 plus 10 by 1. Okay, let's see the result. Okay, it's between 0 and 1. Scale, as it should be. Save the output. Exam is over. I would like to add a few comments on the most typical and most strange mistakes. The first one is this question here. Display through appropriate graphical and non-graphical tools a description for variable alcohol and caffeine. Some students misunderstood the question and took for granted that the description was for both variables at the same time and not for one variable at a time. Well, okay, it can be misunderstood, so whoever has decided to build a scatter plot was considered to be correct. A scatter plot is a good graphical tool to describe two variables at the same time. Okay. Moreover, when I built this exercise, I had in mind the histogram as a graphical tool to describe a single scale variable. However, in fact, in the course program, also the histogram was present, and the histogram is another good tool to describe a single variable, a single scale variable. Therefore, both histogram and the box plot are good things. So I consider correct building an histogram, building a box plot, building both, or building sometimes an histogram for alcohol and a box plot for caffeine. Anything was to be considered good. Okay, what is not good for sure is building cross-tabulation of frequencies, which are not appropriate tools for scale variables. There are good tools for categorical nominal variables. Another question which raises many mistakes is, let me see, these two, let's say together. Oh, clearly for this one, alcohol, a scale variable, and sex, a binary nominal variable, clearly the appropriate parametric test was student test for two variables, okay, two unrelated groups, and the non-parametric test was his correspondence Mann-Whitney test. While in this case, relation between caffeine and our need, okay, if you check, there are both scale variables. So Spearman and Pearson are good. Okay, so the Spearman correlation and the Pearson correlation. Okay, some students in this case decided to do also the student test for pair variables and the Wilcoxon signed rank test. While both tests can be applied to scale variable, if you check what do they show, let me find out the slides. Okay. So the slides. Okay. So you have a two scale variable. Pearson and Spearman were the good ones. Student test for pair data and Wilcoxon sign rank test for the non-parametric version were in this case wrong. Why these two tests in this case are wrong? Well, check what do they prove. Okay. Student test for pair data compares the expected value of one variable and the expected value of the other. It makes a subtraction between the two expected values. Okay. Same thing for the Wilcoxon. The Wilcoxon, which is very similar, compares the position of one variable and the position of the other. You can compare the expected values of two variables or the position of two variables when the two variables measure the same thing. So, for example, if the two variables involved were caffeine that you drink now and the amount of caffeine, of daily caffeine that you drink now, and the amount of daily caffeine that you used to drink 1 year ago, well, these are two variables which can be compared because they measure the same thing. Okay. A similar thing could be the amount of caffeine that you take in due to coffee and the amount of caffeine that you take in due to other beverages such as Coke or Red Bull or things like that. This can be compared because they measure the same thing. Well, but caffeine and our need, these are sleeping hours, and this caffeine, they really cannot be compared. This is the number of coffees, and this is the number of hours. They measure two completely different things, so they cannot be compared. So here you cannot do things like a subtraction of expected value. In this case, you are dealing with the data which are not paired at all. Okay. So even if when you, in this case, in this case you have two scale variables, they are not paired at all. They measure two things which cannot be compared directly, and this is the reason why in this case the Wilcoxon-Sign rank test and the student test for pair data are not good, so are not correct.